So we are going to graph a linear inequality system. What do all those words mean? So graph means we're going to put it on an XY coordinate grid. Linear means we have a line, and I know they're lines because I have X and Y, nothing squared, nothing square rooted. Inequality means I've got greater than or less than, not just equal to, and it's a system because I have more than one involved. So what are we going to do? First, we start off by just taking one of those inequalities. I'm going to start with the top one, 3x minus 4 is less than or equal to 4. Now that or equal to is going to be important in a moment, but right now let's work some algebra and make this look like y equals mx plus b. So we'll take 3x away from both sides, and then we will divide both sides by -1 to get rid of that negative right there. And when we divide by -1, it's important that we divide everything by -1. And that leaves us with y is greater than or equal to 3x minus 4. Well, where'd that greater than come from? We had less than when you divide by a negative. When you multiply or divide by a negative, actually, you need to flip that sign. So now we are in a y equals mx plus b format. Our slope of this line will be 3. Our y-intercept will be -4. So we will put a point at -4. And then from there, we will go up 3. 1, 2, 3, and to the right 1. And then 1, 2, 3, and to the right 1. And we continue that pattern. And if we do, we then will have a line. Now that line is going to be a solid point, a solid line, excuse me, because we are equal to. So that was why it's important. That's why we care if it's less than or equal to. Now, this is where it is slightly different. Here is where we are slightly different from just a straight equation. There are lots and lots and lots of points that would be a combination of x and y values that would make the y be bigger than 3 times the x minus 4. So we're going to test a point, and usually I try to test 0, 0. Now I do that just because it is an easier point to test. It's right in the middle. When I multiply by 0, it's easy. When I add to 0, it's easy. So what I'm going to do is test 0 for x and 0 for y, and I'm going to see what happens. And when I do, I end up with 0 is less than or equal to 4. Now that is a true statement. And what's nice is if that is true, then every other point on that line, on that side of that line, is also going to be true. So I need to shade in absolutely everything to the left-hand side of my line. So that is the first part of our graphing process. We're now going to go on to our second inequality, which is x plus y is greater than 1. Now, same idea, we're going to put that into y equals mx plus b format, and I'm going to do that by subtracting x from both sides. And when I do, I purposely keep that x first so that it is in y equals mx plus b format. And when I do, I see that my slope here is not -x, but it's -1. Okay, the slope is the number in front of x. And my y-intercept is 1. So I'm going to put a point there. Why are you doing that? So I have a point at 1, and my slope is -1, so I'll come down 1, right 1. Whoops. Down 1, right 1, down 1, right 1. Now you'll notice that this time my line is dashed. Now that is because I am only greater than, I am not equal to. So those points on that line are, it means we could be up to that point, but not actually equal to it. So now we have our line, but now we have to figure out what side of that line are we going to shade. And same thing, we're going to test a point that is easy to see. Now 0, 0 is right here. It's beneath that line. And when we try that, we end up with 0 plus 0 being greater than 1. Now that is actually a false statement. 0 is not greater than 1. So this time when we go to shade, we will need to shade on the opposite side of the line because 0, 0 did not make a true statement. And it's important to shade in everything. And I suggest when you do this on paper that you're doing it with a light pencil, not really shading in too darkly. Now, our actual solution is the portion of the graph that was shaded both times. Now, I have the benefit of being able to erase, which is again why you want to use a light colored pencil so that you can. Our solution is any point at all that is in that shaded region that was shaded both times. Now, it's a good idea, again, to check myself. So I'm going to pick 2 points that were in that shaded part. Let's see, I've chosen 0, 5, and negative 1, 8. 0, 5 is right here, and negative 1, 8 is right here. Both clearly in that shaded region. And now I use some algebra to test both inequalities. I have to test 0, 5, both in 3x minus 4 is less than or equal to 4, and x plus 1 is greater than 4. And you can see here through my algebra that both situations, testing both 0, 5 and negative 1, 8, come out to be true statements, so I know I am right.